Okay, so today we're going to be working on an optimization problem from the 2019 June examination for Maths 130, and it says a farmer wishes to fence an area of 15,000 meters squared in a rectangular field. So before I move on, I know that I'm going to be working with an area of 15,000 meters squared, and they tell me that this area is with regard to a rectangle. So if I move to my diagram on the right hand side, if I label the length by x and the width by y, I can say, well, my area can then be equal to x multiplied by y, and that can be 15,000 meters squared. Okay, so moving on. So he wants to do that and then divide it in half with a fence parallel to one of the sides of the rectangle. So here's our line, and it's depicted in the diagram that they gave us as well, but here's our line, and we're going to see how that line affects our second equation. So they want us to determine the dimensions of the rectangle that will minimize the amount of fencing the farmer requires. Okay, so they want the minimum or something. Okay, cool. So if I think about the amount of fencing that the farmer requires, well, if I add up all these sides, I'm gonna get, well, something is gonna be equal to 2x, which is gonna be x plus x, and if I add up these 3 y's, I'm gonna say, well, that's plus 3y. And if I look at this carefully, I can say, well, that's just the equation for the perimeter. So I have the equation of the perimeter of this rectangle. Okay, and we want to minimize the perimeter, because if I minimize the perimeter, then I'm minimizing the amount of fencing required to make this rectangle. Okay, but the question is, how do I minimize this? If I'm going to take the derivative of that, well, it's going to be in terms of x and y. Well, notice that I have two equations. I still have my area. So I can say, well, that means that y is equal to 15,000 all over x. And keep in mind, you can divide by y or you could divide by x. It doesn't really matter. But in this case, I'm just going to say y is equal to, and we have 15,000 all over x. Okay, you would still get the same answer if you had, well, x is equal to 15,000 over y. Okay, so all we're going to do with this is sub it into our perimeter. So we can say, well, that's the same thing as 2x plus 3, and this is our y, so this is going to be into 15,000 all over x. And let's simplify that even further. So 2x plus 3 times 15,000, that's going to be 45,000 all over x. Now let's take the derivative of the perimeter. So if I say p prime, well, the derivative of 2x with respect to x is 2. Now before I take the derivative of 45,000 over x, this is the same thing as 45,000 x to the minus 1 by exponent laws. So if I take the derivative of that, that's going to be minus 45,000 x to the minus 2. Okay. Now rewriting this is going to be 2 minus 45,000 all over x squared, and this is by exponent laws. So this is my equation, or my derivative of the perimeter, and I want the minimum of this equation. So I'm going to set this equal to 0. So let me just erase this part, and I'm going to set this equal to 0. And remember that this is just p prime. Okay? So if I move that 2 across, I get that minus 45,000 all over x squared is going to be equal to minus 2. Okay? And I'm going to multiply both sides by a minus 1. And if I do that, that's going to cancel out this minus sign and that minus sign. Okay. And the next step I'm going to do is multiply both sides by x squared. So if I do that, I'm going to cancel out this x squared. So I have that 45,000 is going to be equal to 2x squared. Dividing both sides by 2, I get that x squared is going to be equal to, this is going to be 22,500. Now taking the square root of both sides, I get that x is going to be equal to plus or minus. Now if you put this in a calculator, this is going to be 150. And let's think about the plus or minus. So if I think about the dimensions of a rectangle, well, the dimensions of a rectangle cannot necessarily be negative. So we can forget about this negative sign, and this is just going to be positive 150. And it's going to be in meters. So this is the lowest that our x can be, so that the farmer minimizes the fencing required. Okay? So this is my x value, or my length. Okay? Now to get my width, well, I have an equation for y. Well, y is just equal to 15,000 divided by 150. And putting this in your calculator, you get this is just 100 meters. So the dimensions of the rectangle that will minimize the amount of fencing the farmer requires is length of 150 meters and width of 100 meters.